Hey viewers, Alan here. Welcome to my workshop. So carrying on with the Lynx engine, in this episode there's no monumental progress. Incremental, I suppose, is a good word. I made the exhaust pipe, and that was a first for me, playing around with thin wall brass tube, and yeah, there's some learning experiences, but I'm happy with the end result. I sorted out the valve springs and had to make some new retainers, and the tappets weren't right either, so I had to do some rectification on those. And there's various other little bits and pieces, and this actually now brings me pretty much as far as I can go with the engine, because I'm waiting for Greg to finish doing some updates on some of the drawings, particularly the ignition system, because I've got to make a Hall effect sensor thing to go there, and I also have yet to decide exactly what to do with the carburettor. I'm inclined to try to see whether the engine will run on the vapor carburettor idea like I used for the Webster, but we'll see. I might well finish up buying a carburettor. Anyway, let's get into it and see what I've been up to, and I hope you enjoy it. So I want to use a short piece of this brass tube. It's quite thin walled, and it's 8mm or 5/16 diameter. Now if I just try and bend it round something round, it's going to kink. So it needs to be bent around a former or a die, and I don't have anything, so I'm going to have to knock something up. So it's a several stage process. First stage was to grab a piece of tool steel. This is some used, came out of a factory or something, I don't know. It was originally designed as a form tool. Anyway, and I've ground an 8mm sort of button shape on the end, which I don't know how well you'll be able to see. Is a pretty good sort of profile match to the OD of the tube. So the idea now is to make a die. Basically plunge this in, but these flat top cutters don't like taking big bites, so I'll start by roughing it out using the 2mm wide parting tool and remove a lot of the material with that. So let's start with that process. So that's roughed it out, and I'll put the form tool on now. Right, so ready to go. I've turned the speed down a bit. Hopefully that won't be too fast for it. I think at this smaller diameter we might go up a notch. There's chatter creeping in. I always have to go at this slower speed. Didn't even like that. So I'm going to have to clean the sides down a bit first, I think. So then I won't be cutting on the full width. So I'm going to take 0.1 off each side face. Alright, now we take 0.1 off this side. And see if we can go a little bit deeper in the middle. Well, that's looking pretty good, so we'll just check the fit of the tube. Well, I don't know how well you can see that, but that's pretty well spot on. And I was aiming for a groove 8mm wide to match the tube. It's a bit hard to measure it. Yeah, I'd say I'm on 8mm anyway. But regardless of what the caliper, the caliper says, the tube is saying it's a pretty good fit. So now I just have to drill a hole to mount this thing, and then part it off. Alright, well that turned out pretty well. Happy with that. On to the next part of the job. Remembering this is still only a quick and dirty. So I have to mount this die on something, and fished a bit of scrap angle iron out of the bin. It's got a hole in it. I might as well use that hole to mount that onto, and keep going from there. So that's a 1/4 inch hole, but I'm going to drill it out so I can tap it for an M8 screw. It's almost the right size as it happens. Anyway, so let's get an M8 tap in there. And a quick tickle with a countersink. And clean it up and we're good to go. Bolt's long enough to put a nut on the back. Right, so that'll hold that. So I machined up another bit of scrap. I'm going to mount that on the back with a hole through it, and that'll hold the back. That'll hold this end of the pipe while I pull it around. Well, that's the plan anyway. Okay, so I've drilled 2 holes to mount this, and a bigger hole for the brass tube. So hopefully this all lines up. Alright, we'll turn it around. Okay, well that's all looking good, but I'm not sure how it's actually going to work out. When I pull this around, the tube may well kink here. I'm not sure whether I need some sort of a follower which matches the profile of the tube and follows the bend round. So in knocking this thing up, I had that in mind, and if necessary I can hack some of this metal off and make something which bridges across the die here and includes a follower, and I can sort of drag it around. Well, that's a complication hopefully I don't need. So I think the next thing anyway is this is hard drawn, this brass, is to anneal a section of it and see how it all works out. Time for the moment of truth. I've annealed a section of this tube. Just brought it up to just slightly below red heat and then let it cool down naturally. I realised it would be handy to have an index position, so I've just clamped a bit of scrap on the back of this hole so that that'll locate to a known position. And yeah, see what happens. I really don't know whether this is going to work or not. We'll soon find out though. I want to go 90 degrees, so that's why I've got this straight edge clamped here. No, it's kinked badly. So that's a complete failure. I don't know what the minimum radius is I could hope to achieve, but maybe I need to do this. I wanted to keep it tight, so perhaps what I need to do is bend the tube while it's hot. So I might give that a try. No, that's a complete failure as well. Obviously the only way I'm going to get a bend at the radius I want is to have it properly supported all the way around the bend. Back to the drawing board. Alright, third try. I've got a bending spring here. This is meant to go over the outside of the tube, but I don't have one that's the correct size for that. But this one is the right size for inside, so let's give that a try. I don't know how hard it's going to be to get it out afterwards, but we'll oil it up. That can't do any harm, can it? I'm hoping that when I've finished, if I unwind the spring, it will make it reduce its diameter and I might be able to pull it out. But I don't know whether that's wishful thinking. Anyway, we might take this to 45 degrees to start with and see if we can get the spring out. If we can, I'll reel and anneal it and see if we can get the rest of the way. Righto, well, let's see what happens. Alright, well, that's about 45. Oh, I got it out. Let's have a look at the bend. Well, that's actually looking pretty good. So I think I'll re-anneal it and see if I can get the rest of the bend. Fingers crossed, eh? Alright, let's see how we go getting the rest of the 90-degree bend. Well, there's my 90, so that's good. Question now is whether I can get the spring out. Oh, there we go. A tighter bend would have been good, but that's okay for my situation. Well, since that works so well, I'm going to make another one. The exhaust port internally is at 17.5 degrees, so I think I'll bend another one up, which is 17.5 short of 90 degrees, and see how that goes. So I've annealed that. I think I'll try and do it in one go this time. I haven't got so much leverage here, so I'm not sure how well this will go. No, that's only one way to find out. I'm going to call that it. Alright, let's get the spring out again, hopefully. Shouldn't be any harder, it's less than 90 degrees. There we go. Alright, so let's trim this one to length. Well, I learnt a bit about bending thin wall brass tube there, and without a doubt the bending spring was the hero of the piece. But I was able to get a 90-degree bend, but more appropriately for the engine I've gone back to, I think it's about 75 degrees, so it gets a nice sort of swept look off the side of the cylinder head. Right, well, even though this die didn't get the job done on its own, it seemed to work quite well with the bending spring, and I got the outcome that I needed. In any case, it didn't cost me anything, and it's always good turning bits of scrap into something useful. Very satisfying. It occurred to me last night though that if I had made this die, the groove in the die deeper, then I might have got a better outcome. And whilst I'm calling the pipe bending done for this project, if I ever have to do this again and return to it, I'll try making the die a lot deeper so that the sidewalls of the tube get more support. Anyway, moving on. So what I have to do now is make a plate to silver solder onto the end of the brass exhaust pipe. I'll probably use a bit of brass for that, and then a 4-hole bolt pattern to fix it to the side face of the cylinder head. I've done most of the work with this piece on the end of a piece of bar, a bit of scrap I had hanging around, and so I did the whole pattern and 3 sides, but then cut it off, and I'm doing the 4th side now to bring it to correct width, which is 13mm. I've got one pass left to take at 0.5 millimetre, hopefully. Shooting for 13. At 1308. That might, close as that is, that might be too much. Yeah. I have to recheck the spacing between the fins, which is what sets that dimension. Okay, so just check that fin spacing, and it is exactly 12.95. So I can't, even a hair over 13 is no good, so I'll have to take another cut. So we're on 12.99 now, so I think, again, close as it is, it might, oh, just jumped to 13, we might still actually be slightly oversized. It has to go in, it's no good if it won't fit. The question is though whether or not I should be shaving this side or that side. And I'm wondering if my best option now is actually to take it out and offer it up and then get it to size with a file. Okay, after a couple of licks with the sandpaper, that fits in there perfectly. I haven't tried to get the screws in yet, but I'm pretty sure they're going to line up. Alright, well I think the other two screws are going to fit, I just won't do it at the moment. So in getting ready to solder these two bits together, I noticed that this plate has a slight bend in it. Now I don't know whether it will show up to you through the camera. It's a very slight bend, but it's a bend in the wrong direction. It's like that, which means when this is bolted down to its face, there won't be much contact right in the middle here, or certainly any pressure on that centre bit. Now the exhaust pipe's open to air, so there won't be much pressure, but it would still be a lot better if the bend was the other way, so the screws would pull the middle down against the sides. So I'm going to try to reshape it slightly. Now anybody who's played around with this sort of stuff would realise that to unbend something you have to take the bend back past the original position. Well, I've actually got a raised ridge here, so I can't just turn it over and bend it the other way. So what I'm going to do, or what I'm going to try, is put it back on this jig. So I've mounted this thing, and I think this is probably more accurately called a fixture than a jig, but I get a bit confused sometimes. Anyway, so I have the thing mounted with a cardboard shim under each end, leaving the middle unsupported. But I think maybe you can see that raised ridge, which is why I can't just turn it over. Anyway, so the middle's unsupported, and I've got a small ring here which just nicely fits over that, and that's going to allow me to press and hopefully get a bit of deformation in the right direction. I'm not looking for much, and it'll be very easy to overdo it. Let's see how we go. Right, so we're going to put a very gentle squeeze on. I don't know whether you'll be able to see it move, hopefully you will. Now that's just moved a bit there, and I'm not looking for much, so I think I'll give that pull that out and see if that's done the business. It's definitely improved it. It's pretty close to flat now, but it looks like it could go just slightly more to put a positive curve in the right direction. So we'll just give it slightly more, I think. It's hard to tell, but I think if anything it's either flat or it's slightly in the direction I want it to go, but it could still go a bit more. One more squeeze. There. That's definitely it. So that last squeeze definitely did the business. I don't know whether you'll be able to pick this up because my fingers are moving, but there is actually a very slight rock now on the piece across the middle, which means that when I do those 4 screws up, the middle will clamp down, which is what I was shooting for. So, happy with that. So I've silver soldered the flange on, given it a quick clean up. Haven't polished it or anything at this stage. Struggling to hold that in the picture for you. Anyway, that seemed to go alright. And I cleaned the back up, and it's time to put it on, see what it looks like. There's not a lot of room to get these back screws in, but they do go in. This actually turned out easier after I got the cap head screws. Trying to do this with the Phillips head ones was somewhat more awkward. I have to make up a gasket yet, I haven't done that obviously. I think that'll look alright when it's got a bit of spit and polish on it. In any case, that's all I'm doing with it for now. So I have some information from Greg about the valve springs, and basically they should compress with less than 1 kilogram of force. Well, this guy here, if I can very crudely show you, takes about 2 pounds or just under 1 kilogram. So I reckon that's got to be somewhere near the mark. I'll use those springs. I've got a pair of them. Now the other thing is that the E-clips that I could get, oh, these are tiny little things. I'll just try and hold it up so you can see it. You probably know what an E-clip is, but just in case you haven't heard that name for it, it's probably out of focus, can't tell. Anyway, it gets its name from its shape obviously, but it's still a spring clip. Now the valve has a 0.5 millimetre or thereabouts groove around the top of the valve stem, and that E-clip has to clip into it. This is a valve spring retainer made to the dimensions on the drawing, with a 5 millimetre bore and a 6 millimetre boss for the spring. But I couldn't find an E-clip which would work with that. So now I've grabbed those springs. These springs have a 7 millimetre diameter bore, which works out quite well. I've made new retainers with a 7 millimetre boss and a 6 millimetre bore, and that E-clip will just fit neatly in there. So that's what I'm going to use. Let's see if we can get that assembled now. That's a good game too. The springs love going sproing. And the only way to defend yourself against that is to have spares. If you haven't got any spares, you're in trouble. That's my experience anyway. So while I was sorting out the E-clips and doing, testing all the way things went together, I decided that that tappet's too tight in the bore. I was originally thinking it would loosen up with wear, but I don't want to take the risk of it getting stuck in the bore, because once the valves have got the retainers on the top, if that goes below the surface of the cylinder head, I don't know how I would get it out. So I don't want it to get stuck, don't want to take the risk. And now the wretched thing has stuck in the bore, very lightly, but at least in this situation I can push it from below. So anyway, I want to really polish, I suppose, the OD of this. I'm really not wanting to take much off. I've made up a loose centre, which is a really good fit in there. Just got to push the air out. Right, and I've made sure this face here of a backing piece is hollow, slightly hollow right in the centre. Oh, and I didn't show you. This piece here, I've hollowed the centre out so the contact patch will be around the circumference for maximum torque transfer. Right, so now if I wedge that in there, with a bit of press on it from the tailstock. Alright, I'm going to take it out and see how it feels. That's the beauty of this setup, it's actually easy to take it out and check the fit. Yeah, I think I'll touch that with some emery paper. So I think if I now give that a polish to improve the surface, polish with a Scotch-Brite to improve the surface finish, I think that might be there. So I've got the valve spring in there now. I think you see that's just good. Alright, well, let's have some fun. You can see the recess in the top of the retainer. The E-clip is supposed to finish up in there. Right. Coming out. Even with these larger bores, it's quite a close fit. That went on the floor. Thankfully I've got a box full of these things now, so I'll probably be able to find that since I've got spares. So let's see if we can get this thing put together. I'm going to start off with leaving the spring clip there. Yep, so it's now in that recess and can't fall out. Oh, alright, well that was a bit of a mission, wasn't it? I'm not sure how much of that I'll leave in with the editing, but oh dear, oh dear. Right, so that only leaves putting this little fellow in. That's compressed air. Alright, it won't go any lower at the moment because the valve can't go down. I'll show you why. To assist with that assembly operation, I had a spacer here to stop the valves from coming down. That's what we want to see. Right, that's the valve assembly. Now I'll put the cam on and see if it all works. Of course, the one problem with all this lot is I still haven't actually set any valve clearances. But yeah, one thing at a time. Well, and I'm pleased to report the camshaft is opening and closing, opening the valves, and the springs are closing them. Look at that, eh? Minor miracle, isn't it? So with the new valve springs in, I was interested to see what difference it made to the leak down rate. I think you can see it's made things a lot better. And I've only got 4 head bolts in at the moment, so it's possible there's some leakage past the head gasket as well. But anyway, that's very encouraging. I think the valves with their new valve springs are going to be okay. So I'm starting to put all the last bits and pieces together here. So when I did the conrod and the piston, I only inserted one of the bearings in the big end, but there's supposed to be 2. And I thought, I was just about to press this one in, and I thought, oh well, wouldn't do any harm actually to have a bearing spacer there. So that's what this is. It's a scrap of aluminium. Why don't you want to go in? Alright, I think this little gadget will give this the persuasion it needs to go the rest of the way. There we go. So now I've just got to get this bearing in there. There we go. So hopefully we can get that onto the crank pin without too much trouble. And make it start on the second bearing. I don't think I'll push that on any further at a stage until I've got the cylinder on. We can see where it needs to be. I'd like to have shown you a better picture of the bottom end of the engine going together, but I couldn't get my hands out the way. Anyway, crankshaft going round, conrod going up and down, and piston going up and down. So I think the bottom end of the engine's looking pretty good.